Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Talking about isosceles and equilateral triangles here, and I kind of want to relate this to some of my other videos just because sometimes you may not have watched them and you might need a little touch up on some geometry of other type. So let's just go ahead and I'm going to draw just a random right triangle. Okay. So here we have a right triangle, and we know it's a right triangle because it has a 90-degree angle. Now I'm going to use this side and I'm going to use it as a reflection side. So since this is 2 to the left, I'd have to go 2 to the right. And of course, that would go ahead, and if I connect, now I know without a doubt that this is the same length as this. Okay? I also happen to know that this is the same length as this. And I also happen to know that this angle matches this angle, all because of reflections, right? I know they're the exact same size. So when I look at this outside triangle, what I notice, let's see, it goes 1, 2, 3, 1, 2. Oops. We'll put the left side here, 1, 2, 3, 1, 2, and the bottom is 2, 4 wide. So I'm just going to draw the outer shape without all the stuff on the inside. We mark these as being the same, and we mark this as being the same. So the outer triangle is actually what we call isosceles. Okay? And what's really important is that you have 2 congruent angles and 2 congruent sides. Now, I do know that some students have a hard time of understanding that something about this. So we have this angle right here. See if I can open this up a little wider so it matches it a little bit better. And I'll just kind of, okay, this is our angle right here. And it's opening up to this side. So this angle goes with this side because that's how wide the mouth is open. So this angle here opens the mouth this wide. So this angle opens up to this side. Because again, when you use the left side of the angle and the right side of the angle, that's what it takes to connect them. Okay? This angle here matches up to this side right here. Now, I didn't mention the top angle and I didn't mention the bottom because we don't have a relationship between them. But the pink and the green angle are the same length, and the pink side and the green side are the same length. So that's what must be true in a isosceles triangle. Okay? So if you have 2 congruent angles, you have 2 congruent sides. If you have 2 congruent sides, you have 2 congruent angles. That's just the way it works. They have to go hand in hand. So definition of isosceles triangle is that you have 2 congruent sides, 2 congruent pairs of angles. Or not congruent pairs, but. Okay, so what happens if they give you some random triangle now? Okay, we're going into the world of algebra. And you see this. (28 degrees, mark, 5x plus 9 degrees. Solve for x. Okay. So we know that triangles add up to 180 because that's the triangle angle sum theorem. But the question is the 5x plus 9 spot the same as the 28? Okay, so remember, this angle goes with this side, and this angle goes with this side. Oh, the 5x plus 9 was not mentioned there, right? This is the other one that matches. This is the other 28-degree angle. So it's really important that we understand that. So now we have 28 plus 28 plus 5x plus 9. And when we add our three triangle angles together, we get a sum of 180 degrees. Now that we've done that, we can combine like terms. So we get 5x plus 65 is 180 degrees. Subtract our 65. So you didn't think you were getting away from algebra. We got to have some algebra practice in geometry. We're back down to 115, and then we're going to divide, and we're going to get 23. So x is 23. It does not need a degree label because it is not an angle. It's a variable. Okay. And 8x minus 3. All right, so here, this congruent side, those both go with the congruent side part. So since they both go with the congruent side, they're congruent angles. Since they're congruent angles, they have the same measure. There we go. So 12x, when I add the 4x over, I'll add the 3 over 12, and we find out that 1 is what x equals. Could I substitute it back in and find out that they're both 5-degree angles? Absolutely. Could I then realize that the picture is drawn very poorly? Sure. This isn't about drawing perfect pictures. This is about, drawing enough that we can do what the problem is asking us. All right, so in this next one, you're going to solve for x, and you're going to find the length of every side. Okay. Whew. They've marked the angles. What sides? But I need sides, right? This was a mess up. This is not. I almost wrote a plus sign. Okay, well, this angle goes to that side. This angle goes to that side. Oh, now we know what sides are equal. It's an isosceles triangle because we have two angles the same. So now we can come over and say, hey, 4x plus 5 must be equal to 8x minus 1. So add the 1, subtract the 4x. We find out 1.5 is the size of x. Okay, so AC is 2 times our x, so 2 times $1.50 is $3, plus 11 is $14. BC, 4 times $1.50, right? That's $6, plus $5 is $11. And 8 times $1.50, that's $12 minus 1 is 11. So AB is also 11, which we knew because AB and BC had to be congruent. All right, so here we have a theorem. It really doesn't have a special name. But when you have an isosceles triangle, and you have a segment that bisects the vertex angle. That means the one at the top that's, well, the one wherever that's not matching the other two, the non-congruent one. Then it will also be a perpendicular bisector of the other side. And I like drawing my isosceles triangles vertical, so let me just show you what I mean. So here I have an isosceles triangle. Okay, these sides are going to match. So if I have a segment that's going to bisect the vertex angle, which means it's cutting this angle in two equal parts, it's going to wind up also making a perpendicular bisector here because these angles are the same and things like that. It's actually your fold line. It's your line of symmetry is what you've actually drawn here. And so we can use that symmetry and the symmetric relationships to really find a lot of information about things. So let's say I give you a triangle. All right. All right, and RS is going to be congruent SP, and they are both going to be 8. And SQ is right here. And this is going to be 5. And this will be 31 degrees. Could you find the measure of angle SQR? So SQR, because it's isosceles and oh, I forgot to mark this. There we go. Because of the fact that it's isosceles from the 8 and the 8, and because these are congruent, even though my picture's bad, that forces it to be a 90-degree angle. Okay. Now, could we find the length of P to R? Well, P to Q is 5, so Q to R would have to be 5. By our segment addition postulate, that would be 5 plus 5, which is 10. Okay. Could we find QS? Well, we see a right triangle, correct? So 5 squared plus however long QS is squared is going to equal 8 squared. So this is 25 and 64, right? Making sure my brain wasn't messed up, that it really was 39. So QS would be the square root of 39. 39 is a reduced radical because it's only 3 times 13, and that doesn't work, so we can't do much else with that. However, what we do know is that it's approximately 6. So we definitely can solve for those things, and we can utilize that very helpful. Now, just because we draw something like that doesn't, I don't always draw them perfect, and that just happens. The other thing that I said I'd talk about is equilateral. So sometimes I call it equilateral, sometimes I call it equiangular. Basically, it means equal, right? So equilateral or equiangular is a triangle where not 2 sides are congruent, but all 3 sides are congruent. And if all 3 sides are congruent, all 3 angles are congruent. And therefore, equiangular always has the same size of angles. It never fails. Because all 180 degrees has to be split up evenly amongst the 3 corners, it makes them each 60 degrees. Are the sides always going to be the same length? No, we can, it's kind of like, take a picture, take it to the copy machine. You can make it bigger. The angles don't change. But yeah, these will all be 60 degrees. So if you ever hear equilateral or equiangular, it means all things are equal. In fact, it's a regular triangle. Then it just means things have equal size and equal length, and you can really use that to your advantage when it works out. So I'm going to give us one last little complicated problem, and let's see what we got going. So here we have an image where there are no numbers in it. And I would like us to be able to label every single angle in it. Okay, so what do we got going on here? Well, we've got a lot going on. So let's focus down to one triangle. Let's go with this one. It has all three sides marked as being congruent. Because it has all three sides being marked as congruent, it's equilateral or equiangular, and we just talked about how that means each of the angles is 60 degrees. Okay, well that doesn't help us much over here, and it really doesn't help us much over here. But I do notice that right here, which we have 60 degrees because equilateral. I do notice right here we have a linear pair because we have two angles that make a line. So 60 plus what is 180? If you said 120, you're right. We got the 120 because linear pair. Okay, now onto this triangle. We have two sides the same, which means that angle and that angle must be the same size. So 2x plus 120 has to add up to 180 because we have to have both of those angles. So those two angles have to share 60 degrees, making them each 30 degrees. Which is good because this is the remote exterior and it has to be the sum of those interior. So that works out as well. So don't lose track of the markings because the markings are going to be completely important for you to be able to solve the same problem.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.